Welcome to myprojectbazaar.com. Now we are going to discuss about the project detection of atrial fibrillation in compressive sensing electrocardiogram measurements. Now we are going to discuss about the abstract of the process. CS approaches the ECG analysis, provide the efficient method for semi-real-time encoding of cardiac activities. Is doing so, it is important to assess the downstream effect of the compressions of any signal processing and classification algorithm. So compressive sensing is particularly suitable for the low power wearable devices thanks it to a low complex digital or hardware the implementation that directly requires a compressive versions of the signals through the random projection. In this works, we have evaluated the impact of CS on atrial fibrillation detection accuracies. Hence, in this process, we have three kinds of steps, that is the feature extraction, classification, and performance estimations. So, in this feature extractions, the feature is collected from the signals, then the classification is classified to the signal is normal or abnormal. Finally, based on this performance, we can evaluate the process is efficient or not. By these three modules only, we can justify our process is efficient or not. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. This project consists of the modules such as input signal, pre-processing, feature extraction, classification, and performance estimation. At first, the input signal is taken from the dataset. The dataset consists of a lot of ECG signals which having both the normal signal as well as the abnormal signal. Then the pre-processing is carried out. In this step, we have two stages of pre-processing is there. One is noise removal, then signal limitation. In this noise removal stage, if the signal having some noises means the noisy pixels peak regions will be eliminated. Then the signal length is too much of large means the signal limitation is carried out to shorten the length of the signals. This will improve the performance as well as the speed of the process. Then after the pre-processing was done, we go for the third stage of the project, that is the feature extraction. In this feature extraction, we have four kinds of features is there. First of all, the major and primary thing is the QRS detection, then RR interval, then peak deductions, then some of the local features such as mean standard deviation will be extracted here. After extracting these four features, we are going to combine these four features together to generate the test feature. After generating the test feature, we just move on to the fourth stage of the project, that is the classification. In this classification, we are using the multi-SVM classification, that is the support vector machine is used to classify the signal as normal or abnormal. If the signal is normal, the message box will be displayed as normal, or else if the signal is abnormal means the message box will be displayed as abnormal. After generating the results of this one, we just do the performance estimation. The final stage of the project is performance estimation. We have three kinds of performance parameters like accuracy, sensitivity, and specificity. By using these three parameters, we can justify our process's efficiency or not. Based on that, primarily we have estimating the accuracies. Now we are going to discuss about the initial running procedure of the process. At first, open the MATLAB 2015B and change the current directory. If you want to execute the process, just right click in the main file.m and select the option run. Once you click the button option run, the dataset will be open. In that dataset, there are a lot of mat files will be there. These are the input signals. So the input signal having both the normal as well as the abnormal signals. Select any one signal from the dataset. After that, you just click the button open. Once you selected the input signal from the dataset, the process will be done automatically. Now the overall process was done. I will going to explain the results one by one. This is the input signal we have taken from the dataset. We don't know whether the input signal is normal or abnormal. After getting the input signal from the dataset, we have to detect the peak deduction. So peak is nothing but the peak is the topmost portion of the ECG signal, that is the peak regions. Now the figure 3 represents the PQRST wave as well as the PQRST points. So this is the results for PQRST detections. In this one we have the topmost position as well as the bottommost position. The topmost position is the peak value, then the bottommost position is the values, then Q and R, whatever it is, everything was calculated in this figure 3. After that the features will be extracted based on this signal only. After that the classification is done to identify whether the input signal is normal or abnormal. If it is a normal, it will shows the results like this one, or else if it is an abnormal means the message box will be displayed the identified as abnormal. After that the performance table, this is the performance table. We have find out the performance like accuracy, sensitivity and specificity. The values are plotted in this table, then corresponding message box will be displayed here. So you can see the message box like this. Then after estimating the performance of this one, the bar chart will be plotted to compare the existing versus the proposed one. Thanks for watching this video.